what I want to talk about, this is actually scheduled for last year. So when it comes to doing talks late, I think this probably is a winner. Test smells and fragrances. I want to talk a little bit about the quality of unit tests. You won't find the slides for this on your USB stick. I've only got a few slides. I'm going to do most of it in an editor. That doesn't work either. It's not my day. Okay, so let's see if we can make this work last. Good. Right. Stuff that I do. Things that I care about. I care a great deal about patterns. Patterns are widely misunderstood. There's a lot of people who have this kind of like, if you play a word association game with them, you say patterns, they say singleton. You slap them, they go ow. It's really very simple. Patterns, what is a pattern? It's none of that rubbish to do with singleton. A pattern is an effective technique. Actually, no, you know what? It may not be an effective technique. It is a repeated technique that people frequently apply to solve a particular problem. The quality of the pattern is determined by their ability to apply it in the right context, and also the very simple idea that actually the pattern resolves the problem. So a good pattern is one that resolves a problem, and we understand it, and it's effective, and we can repeat that application. And a poor pattern is one that doesn't really kind of work, although lots of people seem to do it. And then we have poorly applied patterns, which is a pattern that works just in a different context to the one that we're applying it with. Now, all of these relate to the way that I tend to think about how to work with tests. Other stuff I care about, code quality, test quality, and so on. Now, I get up to other things. I don't just write this stuff. I also write other stuff. I write short fiction, which means I tend to care a great deal about the detail. In fact, I write very short fiction, called flash fiction. I care very much about the detail, the value of a word. What does it mean? How things appear. I found there's wonderful crossover between good code and the attention to detail that is required for things like flash fiction, which gives me a faint interest in things like words. So I thought I'd just dig out the origins of the common uses of the word smell, because we use this term, we talk about code smells and things, and I've just talked about test smells, and we're going to be doing that. I'm not going to enumerate test smells, I want you to just keep sniffing, you know, that's the way we're going to do this. So, culling a bunch of dictionaries, the property of a thing that affects the olfactory organs, otherwise, whether agreeably or otherwise. So a smell is just generally anything that your nose can detect, the faculty of smelling. Pervading or characteristic quality, which is one of the things, which is why it's such a good thing to apply to test code, or any form of code. The idea of a pervasive quality, a characteristic. You look at something and go, yeah, not so good, a lot of copy and paste. But you have that idea. And then obviously when we use it on its own, because words are ambiguous, when we use the word smell on its own, we're not normally talking about a good smell. You don't walk into, when somebody says, what's that smell, they're not saying something, we're assuming the smell is not agreeable, okay, otherwise they wouldn't point it out. So there's that implication, and that gives rise to the terminology of code smells. Kent Beck was the first guy to apply this as a metaphor. We revisited it in Poser 5 in the context of patterns. We talk about code smells being a code level problem that creates motivation and context for refactoring. We also identify it with, we say a smell may have arisen from or be equivalent to a dysfunctional pattern, a pattern that has been poorly applied, or a pattern that is not a good pattern in the sense that it does not resolve a real problem effectively. When we use the term fragrance, however, it's a little less ambiguous. We tend to talk about it in terms of pleasantness and sweetness and things like that. Now, I can't remember who first applied the term when, after code smells were referred to, who first talked about code fragrances. You go into a code base and you look, and there are positive things. So we have a nasty habit of resting on the negative. But there are positive things. So, code fragrances. But I certainly saw it at an XP Tuesday-related event, I'm pretty sure, in London a few years ago, somebody talking about this. And this is what we want our tests to be like, because our tests, unfortunately, end up being kind of second-class citizens. And I found even this in my own code a few years ago, even though I was really focused on testing, I found that when I went back to the test, there was something missing. They were kind of like second-class citizens. And all the quality emphasis had gone into the main code. All the debates by the coffee machine were about the main code. But when it came to the tests, there was a lack of shared conversation, a lack of agreement and consensus. But there's a very good reason why we care about this stuff. So, this is a tweet from a few years back from Kirk Pepperdine. He's a Java performance specialist, and he contributed to the 97 Things Every Programmer Should Know book. And he made this observation: functionality is an asset, code is a liability. I thought this was absolutely fascinating, because I've spent the better part of my career trying to convince people that code is an asset. So stop, kicking it around and treating it like rubbish. But this is really counterintuitive, because it tells you why you need to care about the code. Functionality is what people want. They say, I want this to do something. They talk about it in terms of, whether they talk about it in terms of user stories, they talk about it in terms of use cases, PowerPoint, delimited features, whatever, they value the functionality. And I've got to admit, it's the same for me when I write code. When I'm using another library, when I'm using a piece of code, it's the functionality that I want. I'm really interested in that, first and foremost. I may have an interest on the implementation, but it's the functionality that I want. And I'm also saying there's a freedom to be able to change that. Which immediately tells you why it is that code is a liability, and why it is that this statement means that code quality is important, and also tests and test quality are important. If code is a liability, why is it a liability? It's a liability because I've offered somebody the freedom to be able to change their mind about how they implement the functionality. How easily can they change their mind? Does the code resist them at every step of the way? Does it fight back? In that case, we have a bit of a problem, which we like to dub legacy code, but quite frankly, there are systems that are barely 24 hours old, and they already have legacy code in them. This is one of the interesting things about running. I do a lot of workshops for companies, and it turns out legacy code is not something that emerges over years. It can happen in about 3 hours. Yeah. And the consequences of the legacy code can play out for the next 9 hours. So it doesn't take very long to get into legacy. It's a liability because it gets in your way. It prevents you from being able to change the functionality or how you implement the functionality. So it's not an enabler, it's an inhibitor. It's an enabler from one perspective, but let's look at it from a different perspective. It's an inhibitor. That's why you care about it. If something is a liability, you watch it like a hawk. You don't sit there and just leave it off to the side. This tells you why code quality matters. Because it is a liability. You don't increase your liability, you try and reduce it. You corral it, you keep your eye on it. And how do we define the thing that we want from it? We talk about functionality. That's great, but how do we know we have the functionality? Which leads us right into test code. We have lots of different ways of confirming functionality. I'm not going to say that the test code is the only thing, but it's certainly quite good at it. And so that is this idea that the tests have a certain value. And there's even this wonderfully provocative perspective that actually your test code quality should be higher than your production code quality. Because in theory, somebody could come along, let's just imagine, thought experiment. They're very cheap and they don't cause you too much pain. Thought experiment. Delete all your code except for your test code. Now, can you reconstruct the system based on what you have? In most cases, I'm pretty sure the answer is going to be no. But occasionally, you'll run across a very clear set of test cases that actually help you read through and define what it is that's going on. In other words, they tell you what your functionality is. Now, this is really where we want to sort of head. This is the fragrance that we're after. Very much a garden of good-smelling stuff. Heading in this direction. Now, I'm not really going to focus just on TDD today. I really want to talk about the idea of good unit tests as a more general concept. But I do want to rest on this very simple idea. As I said, this idea of throwing your code away. I first encountered, in discussion with Nat Price and Steve Freeman, who wrote the rather good book, Growing Object-Oriented Software Guided by Tests. That came out a couple of years ago, but back in 2007 they ran this session at XP Day. Unfortunately I couldn't attend, but the blurb and the way they ran the session are very, very interesting. They made the observation, everybody knows that TDD stands for test-driven development. However, people too often concentrate on the words test and development and don't consider what the word driven really implies. For tests to drive development, they must do more than just test that code performs its required functionality. They must clearly express that required functionality to the reader. That's a really important idea. The idea is that when most people think of testing, they think of it as, I am testing that the code is correct. I am testing that it works. If you ask somebody, it's a very natural response. Why are you testing that? I'm checking that it works. Turns out that the hard thing, in most cases, is defining what we mean by it works. It works is the hard thing here. Yeah? What do you mean by it works? What is the behavior supposed to be? Whether or not it passes is, well, I'm not going to say irrelevant, but it's secondary. What is it that it's supposed to do? So when the test passes, I can say, yep, I was expecting that. When the test fails, either I was expecting it or I know possibly what that means. In many cases, what we have is a mystery, a murder mystery. It's red, it's dead. Why? I don't know, that test failed. What, you mean test 1, 2, 3, 4? Yes. Who named it test 1, 2, 3, 4? I don't know, the person who put it in after test 1, 2, 3, 3. Yeah, if you see numbered tests, that's one of your first smells. It's just like, oh, okay, the test has no meaning. Oh, but and then occasionally you get this because people, I get this occasionally from people who have a safety critical background, which quite frankly scares me. Oh, this is a standard technique. We number all the points in the spec and then we have tests corresponding to them one for one. Damn it, I'm not getting on your aeroplane if that's how you develop this stuff. In other words, you reduce the correspondence by making it unreadable. You actually do the opposite of what you're supposed to. Instead of encouraging traceability, you completely destroy the readability of the tests. Nobody can read the tests in isolation to understand what's going on. They require supplementary documentation that is assumed to be correct, because we know that all Word documents are profoundly correct. Yeah? Intrinsically, Word compiles your English and corrects it and makes sure that, yeah, of course it's correct. You're going to find more bugs per paragraph in a Word document specifying the safetiness of a system than you will find in the code in that system. Okay? It's a fundamentally flawed approach, which almost makes me want to travel by train rather than plane, except that I know that trains are also quite highly automated. So they must be clear specifications that require functionality. This is actually what Nat and Steve did. They gave people simple little problems, toy problems, prime number classifiers and things like that, that you could describe on an index card. They gave it out, people in pairs sat there, coded up with tests these little problems. But they didn't just give the room one problem, they gave different pairs different problems. So then what they did, this is the real point of the exercise, are your tests really driving your development, is they got people to pass their test cases over to another pair who were solving a different problem, but without the code and without the original index card. So the other pair now had to write tests that passed the original, that fulfilled the original spec. Not simply passed, but fulfilled it. And this is where it becomes tricky. We find that most things are not written with this style. Now, there are a number of things that are a problem. One of them is occasionally the tools that we use. This is taken from NetBeans. I think that's Oracle's Java environment. I normally use NetBeans because I rarely offend anybody by saying bad things about it. Because if you're not doing Java, you won't be using it, and if you are using Java, you won't be using it. This also relates to a conversation that I've had more than once, but I remember the first time I had it, 10 plus years ago, at a conference, at an exhibition, at a conference, and somebody from a company that provides testing tools asked me, was I interested in unit testing? I said, oh yes, very much so. I said, well, we've got a really cool got really cool stuff. Our system generates tests for your code. Or rather, our application generates tests for your system. I thought, wow, that's amazing. I said, how do you do that? And he said, well, it goes through all of the code. And I said, I'm using test-driven development. Oh, that's okay. Clearly, the person had not come across test-driven development. I said, I'm using test-driven development. And he said, that's okay. We just take the code base. I said, there is no code. So how are you going to generate tests against code that doesn't exist? If I write the test first, how are you going to do that? Oh, so this kind of flawed the individual somewhat. But even then, we still find that there are problems with generated tests. Now, generated test cases come in lots of different shapes and sizes. They sometimes come at the utterly superficial level, which is one of the most common ones, like this. In other words, what you do is you point your wizard, more like a kind of sorcerer's apprentice, you point it at your class, and it says, right, I'm going to generate a set of stubs. I'm going to generate one test method for every single method that is in each is in that target class. Now, the first thing is this may be one of the most useless pieces of code generation ever created, because it doesn't actually solve a real problem. The problem that it solves is the problem of matching curly brackets and writing public void. That's all I can think, which I never found to be one of the major bottlenecks in software development. Because what you're left with is a whole load of empty stubs, normally with a to-do in the middle, like the real work, to-do, the real work. We haven't actually saved any time. But it has a far worse effect, far worse effect. It actually causes you to write bad tests. So not only does it not save you time, it encourages bad style. We're going to describe why that is bad style in a moment. Now, there are other more comprehensive test generators which will look at your code and they will generate vast amounts of coverage. The only problem is you have no idea what they're doing. They're great for regression, but they don't necessarily actually give you meaning. It turns out that meaning is the hardest thing. That's what we're struggling with. We're not struggling with writing tests because our typing speed is too slow. We're struggling with extracting and communicating meaning. That is the big bottleneck. It is not the idea of testing. When people say, oh, testing's slowing me down, testing doesn't slow you down. When you run a test, it takes a few milliseconds. It's really very, very quick. It is writing the test that may be slowing you down. And it's not the typing speed either. It is the thinking about the meaning. So let's have a look at what the sort of common, which editor have I got this in? Oh, right, okay, let's try that. Okay, so a bit of fun. We imagine a cup. Glass will do. I'm going to keep it really simple. I'm not worried about the private implementation. I'm not worried about sipping from it. I'm just going to knock it back in one. So we can default construct a cup. We can ask it whether it's empty. We can fill it, and we can drink from it, and that's it. When you drink from it, you drink it completely. When you fill it completely. It's as simple as that. So this shouldn't really be too hard. So if we take the kind of perspective, and we go ahead, and so this being C#, I'll use, I'll sort of sketch this out in N unit. So the first thing that I might be tempted to do is write something like this. So what I'm going to do is test the constructor. Because that's what I've got. I've got a constructor. Okay. And what I'll do is take a cup, create a cup, and then what am I going to do? How do I test the constructor? I've set myself up here because I'm going to go one for one. How do I test the constructor? Well, this is a bit of a problem. People sort of say, well, let's just test, in that case, let's test that we've got a cup. Okay. Okay. We pat ourselves on the back, we run it, it passes, we pat ourselves on the back again, we're feeling good, we've got one test case, it passes, fantastic. What's the problem with this? I'm testing, yeah, I'm actually testing .NET. Now, somebody needs to test .NET, but unless you happen to have it as in the scope of your work, test .NET, it's probably not your job. And whilst I think that most lines of demarcation are irrelevant, kind of if we're trying to focus on a cup, why am I testing that .NET works? Because there are no circumstances for a correctly functioning version of .NET that this would ever fail. It's a fancy way of writing assert is true, true, but it just looks a little more credible. But it's lit, you can actually see it all over test suites. Very, very common, because people are looking for a thing to test, and they pick up the nearest thing. And it's like, oh, I've got a reference. Right, what do you do with references? You check they're not null, because that's what you do with references, it seems, most of the time. I saw a system last year that was pretty much, I think, if you actually measured the CPU in terms of, if you could actually get down to that level of granularity, I think it spent most of its time checking for null. Okay, the code base was a nightmare, and there was no confidence. So we got a reference, quick, check it. Now it's okay, what do we do with it? I don't know. Functionality? Who knows? So assert is not null. This is unfortunate, because new, if it fails, will throw an exception. The constructor, if it fails, will throw an exception. In other words, there is no point at which we will ever execute that assertion in a failed scenario. The philosopher Karl Popper gave us a kind of workaday definition that we now use to distinguish a scientific theory from conjecture and fluff and woo, which is basically, scientific theory is one that can be falsified, that you can create an experiment whose negative result would demonstrate a flaw, if not the complete failure of a given theory. It must be falsifiable. In this particular scenario, there is no code that I can write that will cause this to fail. It is not falsifiable. Now, the same argument does not apply if you start using, if you decide to use a factory method. If instead of using a constructor, I decide to use cup create, that suddenly becomes legitimate. Because I have taken away, because you're not messing with new anymore. I can't see the new here. It's perfectly capable, it's perfectly easy for me to go and write a create method, a static create method that returns null. So it's not to do with the creation, it's to do with whether or not you are testing the language feature. If your test code is testing a language feature, then that's not a good thing, unless you are a compiler writer. If, on the other hand, you have hidden that away, then there is a reason to test it, because you may be specifying it. There may be circumstances under which you choose to return null. Okay? And it's entirely up to you. Maybe you chose to use a static constructor method because you prefer the naming conventions that you might get. I mean, although whenever people tell me that and they just use create, I'm kind of always wondering, that's not, you haven't really used the bandwidth appropriately. New is actually much clearer in this case. Sometimes people will come up with superstitions that they've heard from other places. Oh, you're not supposed to throw exceptions from constructors. It's like, what kind of nonsense is that? I'll talk about that tomorrow. That's a kind of superstition that people pick up. And they say stupid things, they say things like that without realizing it. And they say, oh, well, in which case I'll wrap it in a static method, the actual construction, and then I will throw an exception from the static method because that's okay. So sometimes people will use static methods for completely bizarre reasons, unfounded. Sometimes they will use them for correct reasons and appropriate reasons. In this particular case, we're not gaining anything by it, so I'm going to roll it back. Where I can see the behavior, because new is fairly unambiguous. Okay, so I can get rid of this. Okay, so I can get rid of that. This actually is testing something. The successful execution of the test constructor method, the successful execution of this will suggest that the constructor did not throw an exception. But that's quite a grand claim for the name. it's saying test constructor when all it's doing is really just test that an exception is not thrown. It doesn't test that it's correct. It just says, well, let's just assume that it doesn't completely fall apart. But we don't know that it's correct. We haven't demonstrated that. So the name is a bit grand. It is still testing something, but it's not really testing quite, it's not living up to its name. So let's try something else. There is a thing we can test. And that is assert the cup is empty. Seems entirely reasonable for a new cup. Okay, we'll start with that. So the cup is empty. That's good. So that's satisfying. And that is, of course, very different to assert is false, cup is empty. In other words, you get a pre-filled cup. Now, this looks remarkably like copy and paste. I assure you it's an artifact of the projection. Okay, let's go, given that we've got, given our method list is our to-do list, tick, we've tested the constructor. Let's move on to is empty, the is empty property. Test is empty. Cup, here was you cup, test this. This is hauntingly familiar. Maybe I did copy and paste. Well, now I'm testing the is empty property. Okay, but what am I really saying here? Have I said anything new? Well, I've said already what we already knew, which is, we knew that. So this suggests a couple of courses of action, one of which is delete duplicate code, so I could get rid of that. Yeah, that would be a possibility. The other is go ahead and test something else to do with is empty, which is the option I'm going to take, because we know that is empty returns bool, so therefore we've only tested that it returns true, we have not tested that it returns false. So we need to set it up to return false. Seems entirely reasonable. We already have a method for doing that. We fill it. Great. Okay. Right. And now, okay, right. Tick. Right, next thing. Let me throw another smell at you here, which is oops. I see this a lot. We assert, and then we assert again. Well, we assert what we already know, then we fill it, and then we do just. And sometimes people say just to make sure. Well, okay, let's be very clear. When we talk about just to make sure, did you expect that the first test would pass, and then somehow the inherent truth that you've established, that new cups are empty, is somehow violated between one test and another? If that is a possibility, quite frankly, I would stop worrying about cups. You have other issues with your it's really not your problem anymore. You have such an unstable setup that any new development on it is a waste of effort. Okay? Now, the problem here is that you're going to end up with an ever-growing list of assertions that you might want to do as you progress down your tests. Because you'll keep adding, well, I now want to check that all the things I already knew to be true are still true. Let them be. You only need one test failure to turn the whole lot red. So we don't need that. Now, sometimes people will try and economize and say, well, I see what I'm doing here, and they will also just say, well, it's a precondition that the constructor works. Okay, so you kind of get this sneaking in. Well, actually, you know what, I'm not really sure about that one. So what we're getting here is A first obvious difference. Test methods are not for calling. They are only for calling by the testing framework. They are not for calling by you. You should never call another test method. You just certainly don't create when we talk about a testing hierarchy, we don't mean a call hierarchy. So there's a fundamental difference between the conventions and practices that we would adopt for conventional production code and this. The point is you've already got it being called. It's there. That's automatic. Now sometimes people feel very uncomfortable with what this is called implicit invocation. Yeah? Because you don't see the call. People don't feel comfortable unless they wrote the call. Now I know it's being called. You see, I can see test constructor is being called there. But it's okay, the framework will do it for you. So this doesn't add anything except the possible scope for confusion. Yeah? It also, it's one of those things that occasionally when you look at it, occasionally if you clarify with the developer, why do you put that in? They're just being sure about something or they wanted to make something explicit. Another way of reading that is, I have no idea what NUnit does, or I'm not really sure about testing. They're compensating for a discomfort that they have, which is natural enough. People get uncomfortable with new stuff or stuff that's different. So, yeah, it's a minor point, but let's get to this. So we've now got another test. This is great. Okay, so let's move on. Now it's going to get interesting. Test fill. We've already used fill. Okay, what can we test? Have we tested all the possible behavior of fill? What else can I do with fill? I can fill a full cup, yeah? In which case we get an overflow. Yeah? So I'll put that in as an expected exception. We'll come back to other stuff. Okay, so let's do that. Imagine that we have an overflow exception of some kind. And we do that. Okay. Right, so we go around here and we tick. Something that people occasionally want to do is add in a setup method. Setup. So now I can go through and get rid of that, and that. Now I'm not going to say setup methods are a bad idea, but I will say they're often not a good idea. This setup method has now not factored out it's made each test case less self-contained. There are certain conventions that we follow in production code that we try to don't necessarily apply in test code. In this particular case, we factored out private field, cut, a way of initializing it, setup. And now when we go through these, test constructor, this is the funny thing, I don't actually see a constructor being called. There's this curiosity that, although I've said I'm testing a constructor, where is it? Where is the constructor called? Because if that constructor call fails, it'll actually fail during the setup. So I've although a thing that will fail will continue to fail, the challenge here is not that it works, is that what you're communicating to the reader, it's the meaning of the thing. I've kind of wrong-footed them here. And to be quite frank, I haven't really factored out anything profound. This is not a major amount of work. The reason that setup can be useful is when you have a lot of setup code. Factor that out. And even then, I don't think that the setup method is necessarily the best way to go about it. Sometimes a factory method is a better way of going about it. So you name what it is that is being created. And you give it a name. When people look at the initialization, they can see what it is that you're doing. Also, in many cases, although not in this one, it constrains people to use a particular subset of data. They always end up using the same values. So this hasn't really brought us anything useful. So we're going to go back and we're going to get rid of this stuff. Okay. Okay, so we've got that. Now, finally, we get to, let's see, let's copy that one. Oops, I said copy. Okay, now, if we go to our to-do list, it would appear that we've done 3 out of 4. Okay, and one nice thing is we haven't actually used the drink method yet. Yes. So first, this is the first time we're actually going to see the drink method in action. So we can feel good about that. We fill it, we drink it, and then it's empty. So finally, it looks as if we've actually got a method, test method, that corresponds, or at least names for the first time in the code, the method. But if you're actually fairly careful, you'll realise we've actually used every single method in the cup. Constructor, the isEmpty property, the fill method, and the drink method. In other words, in order to test the drink method, we've used the whole class. It's a kind of slightly Pyrrhic victory in that sense. Okay, but here's the problem. Actually, we haven't tested everything. It looked really good. What about drinking from an empty cup? We haven't tested that. And it's not obvious that we haven't tested that. It requires somebody else to come along and go, hey, you haven't tested that. So, whereas filling a full cup leads to overflow. Oops, I should copy that one as well. Drinking from an empty cup is merely disappointing. Okay? So drinking it leaves it in the same state. That's the only thing we can say. So now we've interleaved our assertions again. Okay, so here is test by method, or procedural testing. We have got a method in the class, and we have ended up with a method in the test suite that corresponds to it. This is one of the reasons, this is one of the most common ways in which people will write test cases. It's obvious, it's intuitive, a one-to-one alignment. It's very difficult to get away from how obvious that is. It's obvious, intuitive, and completely wrong. This stuff smells badly. Okay? If you create a large code base based on this approach, you will find it difficult to maintain your test code, because the behavior is randomly scattered across all the methods. It's not much better than calling them test 1, test 2, test 3, test 4. Yeah? Marginally better. But I could be persuaded that it's not. Okay? It's an arbitrary partition. Yeah? If I want to find out about fill behavior, I need to go and look at 2 methods. The one that's called test fill tests an exceptional behavior, not the main, not the regular behavior. The behavior of isEmpty is tested across 2 different things. So quite frankly, this is not how this stuff works. So we have a problem here. In fact, the easiest thing we can identify this going on here is the problem of cohesion, or to be precise, the lack of it. Now, when people use the term cohesion, there's a lot of confusion. Glenn Vanderberg wrote a really good blog on this a couple of years back. And he talks about the idea of cohesion, because people are very familiar with coupling in terms of dependencies, but what is cohesion? And he talks about it in terms of the idea, a word that shares the same etymology, coherent. We refer to a sound line of reasoning, for example, as coherent. The thoughts fit, they go together. They relate to each other. This is exactly the characteristic of a class that makes it coherent. The pieces all seem to be related. They seem to belong together. It would feel somewhat unnatural to pull them apart. Such a class exhibits cohesion. We refer to a sound line of reasoning, for example, as coherent. Okay, let's just do some word replacement. This is exactly the characteristic of a test that makes it coherent. The pieces all seem to be related, they seem to belong together, it would feel somewhat unnatural to pull them apart. Such a test exhibits cohesion. The tests we've got are completely arbitrary. They have, the test fill method doesn't really test fill. It kind of tests the exceptional behavior of fill. Most of fill's behavior is tested elsewhere. The test drink method uses every single method and actually suffers another interesting case, or another interesting issue. Although a number of although a number of testing frameworks don't use this terminology, it's classic kind of JUnit terminology, test case, I've kind of gone back to using it. NUnit chose not to use it, but I've kind of gone back to using it because the term test case is almost self-explanatory. It's just so familiar we forget that it actually means something. How many cases of behaviour am I testing here? Well, that's two. I'm testing a cup that is empty and drinking from it, then I'm testing a cup that is full and drinking from it. Now, where I come from, we call that two, not one. So how many test cases are there in this test case? 2 into 1 does not go. Okay, this is the problem. And it's a very simple idea. A test case should be just that. It should correspond to a single case. So that's the first thing. Correspond to a single case. Most of those test cases that we had did correspond to a single case, but they were misnamed. We're going to come back to the naming in a moment. But here in the last case, test drink is clearly not a one-to-one relationship. Now, occasionally you see this guideline doing the rounds, and I always feel like I always feel like I'm sort of tearing up the rule book when I go against it. But it's a really bad guideline, and so it shouldn't be doing the rounds anyway. There's a guideline people sometimes follow. A test case should only have one assertion. That's rubbish. That is complete crap, and if you're following that, I suggest you stop it immediately. A test case should test one thing. That's not the same as it should only have a single assertion. If it tests one thing, the chances are it will have fewer assertions and they will not be randomly scattered throughout its body. That's the problem that we saw here. So the first thing is test one thing. Are you testing one thing? Okay. Are you testing the outcome of an interaction, the outcome of a scenario? And this also tells us that the kind of test cases we're doing here, which are not exhaustive test cases, in other words, I'm going to throw thousands and thousands of data items of authentic data at something and see that it doesn't fall over and see that it matches some kind of validated gold standard result. What I'm doing here is I'm characterizing the behavior. I am specifying. Okay, so I'm specifying these basic behaviors. And it turns out these tend to follow a very similar narrative. Now, in 97 Things, I managed to get Gerard Mazaros to submit an item. Now, I was very pleased with this because it's a really nice item. But Gerard wrote a book called X-Unit Test Patterns, patterns for testing, using various unit testing frameworks. It's quite a hefty book, about 1,000 pages. Not to be treated lightly or taken lightly or even thrown lightly. It will cause great damage to your colleagues when you throw it at them. No, that's not how you test. So it has a certain force. You can use that. But I managed to get them down to about 500 words for this. In a piece called Write Tests for People, immediately we invoke the idea of an audience. Who should you be writing the tests for? For the person trying to understand your code. Note that he does not say for the person trying to understand your tests. That's different. It may be the same person, but what you're doing here is observing that good tests act as documentation for the code they are testing. They describe how the code works for each usage scenario. That's what your test cases should be aligned with, and therefore how your assertion should fall out. For each usage scenario, the tests describe the context, starting point, or preconditions. Yeah, in BDD speak, this is given. Given this, when illustrate how the software is invoked, then describe the expected results or postconditions to be verified. That's where your assertions go, the last bit. Now, importantly, sometimes this means that there will be a single assertion. Sometimes it means there will be two assertions. Sometimes, depending on your language framework, your language and framework, there will be one assertion, and exactly the same logical assertion in another language would be rendered as two assertions. Okay? So don't rely on something as brittle as it must have one test case, because what you find is when you move between testing frameworks, what used to be one framework may become two. Oh, sorry, what used to be one assertion may become two. It becomes very, very brittle, and it's mostly a matter of perspective. But you're still testing one thing. The other thing to look out for is occasionally I get people saying that when they use mocking frameworks that they're only testing one thing. Every expectation is an assertion. Okay? So whenever anybody says we follow the one assertion rule and they have a mock that takes more than one expectation, then they are not following the single assertion rule. An expectation is an assertion. You can even look it up in the dictionary. In fact, some frameworks use the term expect as an equivalent to the term assert. So expectations are assertions. They are an expectation that something will have happened. An assertion is an expectation that something will have happened. It's exactly the same. So there's a kind of a logical inconsistency in the way people look at that. So although I do review, there's an important observation here. The idea of one assertion per test case is a good review technique, but it's not a constructive technique. It doesn't tell you how to write the code, it just tells you what to look for. If I see lots of test cases with many, many assertions in them, that's a smell, okay? That's a problem. But to tell somebody, don't put more than one in, is not a good idea. That doesn't help them create good test cases. In fact, I had this example a few weeks ago where somebody clearly followed this, and the test cases were fragmented as a result. It's a little bit like a no entry sign on a road, on a one-way road. The no entry doesn't tell you what to do, it tells you what not to do. Okay? When somebody says don't write more than one assertion, they haven't told you how to write a test case. They've actually given you a sign that says don't do this. They haven't told you what to do. So in other words, the advice is not constructive, it's not helpful. And this is important. The advice that we use for reviewing is not the same as the advice we use for constructing. You may observe that there are many assertions, but not putting assertions in is not the way to make good test cases. So you need one logical outcome. You need to be testing the outcome of something. If you feel, and that immediately eliminates most of the crappy test cases, but also gives somebody a constructive approach. Now, when we say constructive, what do we mean by constructive? How are we going to name these things? Okay, let's try going back up here. So, test constructor. Well, obviously the test word is noise. We could have got rid of that before. Constructor, not helpful. Let me just go up here and just get rid of this. Let's just assume that the the first is just private stuff. This can be default constructed. It has a default constructor. I just haven't provided it. It's provided by the compiler. The language defines it for me. Does that mean that I get rid of this test? No, it just tells us what we already suspected, that it's completely misnamed. What we're doing is we're testing the initial outcome. We're not testing the constructor. We're not poking and prodding the constructor. What we're doing is we're testing something about a new cup. And however we got the new cup, that's what we're testing. And it doesn't matter whether or not we used field initializers or whether or not we initialized the fields in the constructor that we provided, the test remains the same. So don't make your test brittle, dependent only on the code that you write as opposed to what the compiler will provide. So this has nothing to do with constructors. It's about the initial state. A new cup is initially empty. Oh, okay, there we go. It's very difficult to argue with that. Or rather, you can argue with it. But Kevlin, we're now providing a new line of cups that are going to be pre-filled. Now this is important because it tells us something here. So a lot of people get halfway with this. In fact, I got halfway with this years ago. New cups. Okay. So I've got away from pointing and poking at pointing and prodding the constructor. I'm talking about new cups. Great, but I'm leaving the reader in suspense. A new cup, yes, and? Is it full? Is it empty? What's happening to it? So I've not really told you what's going on. So the idea is tell the reader what's going on. Then they can discuss on the correct terms. Most debates that people have about what they consider to be implementation details are actually discussions about requirements or usage. So often you'll find two developers looking inside a method, disagreeing about what it does. And actually, they're kind of arguing about what it's supposed to be doing, which is different from have they implemented it the right way. It's a different debate. So under this assumption, if you went and looked at my constructor, if it ensured that a new cup was initially empty, and then you said, actually, no, new cups should be full, then there's nothing wrong with my implementation. What is wrong is my expectation. In other words, I've got the correct implementation for the wrong requirement. Most discussions about the code are not about the code, they're about what it should be doing, not how it's doing it. Okay? So the idea is to separate out the discussions, make the name so clear that I can see exactly what our assumptions are. So, yeah, new cup is initially empty. Now, I also fall under the idea that this should be human readable. Use spaces for spaces. Okay, I'm not saying whether or not you should use this in other code. I will talk a little bit about that, what the upper limit is for that tomorrow. But what you're going to find is with this naming convention, your names will become longer. There is an upper limit to what you can read when it's in multi-capital form. Okay? Camel case is not the way that languages based on the Roman alphabet were structured. Their spelling doesn't work like that. The way that you read doesn't work like that. It doesn't matter how many years of experience you have, it will always be harder to read that. You can fool yourself into thinking you're good at it, but it will always be that little bit harder to read than something that has spaces. So use something that has spaces. The best we can get in this particular context is an underscore. Visual separation. Write it like a sentence. In fact, this also helps us do something else. It gets you away from your normal naming conventions. Okay? This is important because the normal naming conventions that you use serve a completely different purpose. Your normal naming conventions are based on noun phrases and verb phrases. Noun phrases, for example, for class names, and verb phrases very commonly for method names. You have years of experience and habits for how to compose these, some of which I'll deconstruct tomorrow, but the point there is that these are very familiar. You know how these work. They serve a purpose. They serve a purpose for code that is calling your code. But I pointed out earlier, your code is not being called here. So therefore, this is more of a fragrance than anything else. We're making sure that you use a different practice to get a different result, a different practice for a different practice. We are naming code that will never be called explicitly. So therefore, the violation of the .NET guidelines in this case, or the Java guidelines if you're working in Java, or well, each language has its own culture of naming, within and its own culture of conformance to naming. So that's a little more visible. Okay, so new cup was initially empty. That tells us exactly what we wanted. A filled cup is not empty. Aha, right. So filling a full cup causes overflow. What you're doing here is you're communicating to the reader some concepts. These concepts are obviously blindingly obvious with this toy example. We already understand what filling and emptying and so on mean. But what you're doing in many other cases is you're trying to communicate a state or relationship concept to readers. When it's in this state, when you do that, this happens. We're making a very clear communication about what we mean by filling, emptiness, and the actions and consequences of doing things in certain states. It's a very simple state model, but nonetheless, that's what we're communicating. When we skim off these names, a new cup is initially empty, a new cup, that's kind of redundant, I now think. A cup is initially empty. That's the great thing is you don't even have to refactor this stuff because you're never calling it. A cup is initially empty, there we go. A filled cup is not empty. Filling a full cup causes overflow. Here we need to separate this out into two. And the first one, let's choose the typical scenario. So normally lead with the typical scenario. Drinking from a full cup. Empties it. empty it as well. Empties it. We want that one gone, that one gone. And drinking from an empty cup leaves it unchanged. So what you now have is there's 5 test cases which are all named in terms of the behavior. These are like mini user stories, but rather than being against a system, they are against an individual object. These should be phrased like requirements. Now, normally the term requirements has been hijacked to mean requirements on a whole software system, but software composition is recursive. You build a big software system out of smaller pieces, and you build smaller pieces out of smaller pieces still, so which gets us right down to the level of objects using other objects. So there is this idea that what you're doing here is you're defining requirements on a class that implements, that you're going to use for objects. But they're not user-level requirements, they're code-level requirements. This piece of code requires this piece of code to do this, otherwise this isn't going to work. Okay? So there is a requirement there. In fact, you might even say it's even stronger than a user requirement, because you can argue with users, but you can't argue with the compiler. Okay? So, but these are kind of micro-level requirements at the level of an object. So there's much greater clarity here, and it would also help if I updated the code. Let's get rid of that. Okay, so that takes us in that direction. Now, the style of naming that we've got here is that of a proposition. Propositional naming, a statement expressing a judgment or opinion, a statement expressing a concept that can be true or false. That's important. The naming, if you look at this, it's actually quite obvious what happens. When you look at drinking from an empty cup leaves it unchanged. When this test case passes, then the result of that is that we have a cup that when you drink from it, when it's empty, it remains empty. That's what we've got. And the clue is in the name. So in other words, the name of your test cases is, if you like, if it's all green, if every test case passes, then what you have is a list, a manifest of the behavior. So the names should correspond to the behavior. Okay? So when somebody says, what does it do? You just read off. Well, drinking from a full cup empties it, drinking from an empty cup leaves it unchanged, the cup is initially empty, and so on. This is a list, it's a manifest of its behavior. So that you want to name it in positive form as propositions. This also helps us when it fails. If one of these fails, then you know what is wrong. You may not know why it's wrong, but you know what is wrong. So, drinking from a full cup empties it. If that fails, then clearly drinking from a full cup does not empty it. It is the negation of the name. It's really easy. There's no mystery as to what test 1, 2, 3, 4 does or does not do. So you know what you've got. It's not, people often focus on what it does, but no, you know what you've got. I've got a cup that has this behavior, or I've got a cup that doesn't have this behavior. Now, this leads me to one thing that occasionally people sort of say, well, okay, by the way, when looking at proposition, it is not an offer of sexual intercourse, although sometimes that's how you feel about the code, and not in a positive way. Occasionally I get asked about, well, what about the should naming convention that is used in BDD? So behavior-driven development, commonly, the cup should initially be empty. If this naming convention helps you get away from the common smell of having procedural tests, then I'm going to be all for it. But this is more like stabilizers, training wheels on a bicycle. If it helps you get going, that's great, but you've got to take them off one day, because it's a really stupid naming convention. Sorry, it is. Let's be very clear. Why do I think it is not particularly effective? First of all, the word should in English. Well, actually, if you're not a native English speaker, should is an absolute nightmare. because it forces the positioning of the verb to be after that is all over the place. But should is it's contingent, it's kind of optional. Should is an optional word. A cup should initially be empty. When I say that, I'm expressing a desire, an aspiration, which may not be met, and it's perfectly understood that it may not be met. A cup should initially be empty, but you know, hey, what? Some of them aren't. And that's okay. That's what you're saying. Yeah? Where are my keys? They should be on the table. When somebody says that, they're immediately acknowledging they may not be, and that's okay. And that's a typical state of affairs. Should is a word that is something you want to get out of any form of writing, to be quite frank. It falls under Strunk and White's fascinating. They talked about assertions. Isn't that brilliant? 100 years ago, the original version of these guidelines from William Strunk. Make definite assertions. Avoid tame, colourless, hesitating, non-committal language. Yeah, if you put should in, it's the first bit. Yeah, it's kind of like, well, you know, it should. You're not making a commitment. You're not saying it must be. You're saying, yeah, it should be. Maybe it isn't. The other thing is, note that when a sentence is made stronger, it usually becomes shorter. Notice that if you put should into all of those test names will become even longer still, but they won't say anything else. Again, I'm going to go back to the fact that one of my hobbies is writing flash fiction. In flash fiction, you care about your word count. You care about it obsessively. You don't want to waste your time messing about with adverbs and optional words like should. You want to be direct. And the should kind of just dilutes the effect of your writing. It also makes it longer. Given that it's already quite long, you better be getting something for the extra distance, but you're not. You're getting hesitation. The other thing is it undermines, before anybody says, oh, well, we should replace the word should with must. I've seen a couple of testing frameworks that do that. That doesn't make the problem, doesn't make it any better. Because I want to go back to the value of a propositional naming scheme, which is a wonderful fragrance to have in your code. A propositional naming scheme emphasizes what you have. You're not saying, I must have this. What you want is that your test names make sense when you write them out. They make sense as a listing of the behavior. Word must and should, neither of those helps. Okay? So be kind of a little more direct here. Okay, now let's just flip over to a slightly, let's flip over a slightly different example. I actually knocked something together earlier on. This was kind of an interesting exercise. I'll have a go at doing this. I will write some code without tests. That was a pain. I was reminded why it is that I write code with tests. Not all the bugs are intentional. So I thought, okay, I'll do a date class, and I'll write tests based. And now I will write tests afterwards based on the way that most people do them. For some reason, most programming languages, the standard libraries of most programming languages, have some kind of desire to not have a date class. I don't know why this is. It's slightly unusual given it's a very common everyday concept. .NET doesn't have a date class, it has a date time, which is not the same thing. If you ask somebody, what day is your birthday, you don't give them the time of your birth. That's just a bit creepy and weird. And Java has a class called date, but it's not a date class. It's a date time class, so it's completely misnamed. C++ thought, hell, we'll just use whatever C gives us. And C gave a rather full but unhelpfully named struct called TM, and so on. Occasionally a language comes across and you go, oh, great, it's got dates that aren't muddled up with date times. So I thought, okay, let's just do this. It's a good toy example. So we've got this thing called date tests. And a constructor is correct. Can compare equal. Get hash code works. Okay, first thing, these are common naming smells. Constructor is correct. Something is correct. Something is successful. Something works. Sometimes even better when you combine it with should. So that should work. It's sort of it's a call for help. It's an act of desperation. Well, I don't know what it's doing, but it should work. Yeah. Naming is hard. Doing this kind of naming is hard. There is a reason it's hard, because it goes back to the idea that it's nothing to do with the typing, it's an act of communication. Sometimes explaining not what the code does, but why or what its purpose is really hard. That's the bit that's slowing you down, is communicating what's very internalised here to somebody else. That's the challenge. It's nothing to do with typing, it's nothing to do with naming conventions per se. It is that. So yeah, it is hard, and sometimes you look at something and go, well, I kind of know what it means, it should just be right. Yeah? But use that when you go back over the thing. If you have anything that's kind of like, da-da-da, is okay, it's just like, oh, and unless you actually have a status flag that is okay, then that's not a very helpful comment, because would you say the opposite? I'm going to check that the code is not okay. Well, that's not particularly helpful. Yeah? Well, it's kind of helpful occasionally if you're trying to say, I stopped work here. Yeah, I'll come back on Monday and finish the rest, but that's about it. So there are these things. There is also another little smell, which I noticed when people kind of try to get away from the procedural naming, that I am testing this method. What they'll do is they will relate to that method in some way. So here we can call the equals method on a data object. So we say can compare equal. If you see can floating around in test names, that's often a smell as well. It's just like can do something. Is that do something a method name by any chance? Are we just doing a one-to-one check there? So yeah, it was really interesting trying to write this code, because writing it without tests, I did introduce a couple of bugs, and then trying to write it so the code was reasonable but the tests weren't, was also quite interesting. So let's see what we've got here. So, okay, constructor is correct. So this is not atypical for the way that people will go about this. var d, new date 111, assert is true.d.year equals 1, and d.month equals 1, and d.day and month equals 1. Now, there's a lot going on, just 2 lines, and there's already quite a lot to say about that. First of all, D, really? Really? Did you just kind of like just totally forget the other letters that you could use? What happened? Okay, I see this so often. It's like, oh, it doesn't matter because it's a test. Actually, it does. Because it's compounded in the next thing by D2. What, R2? Why isn't that called D1 either, if we're going to call the next one D2? This isn't like films, you know, Iron Man 2, Iron Man 3. Or D, the Winter Soldier, or something like that. So first of all, we've abandoned all good naming conventions. So let's actually go back and talk a little bit here about some of the naming conventions. There's another reason that I don't do the factoring out of a setup method here, is name this so that when somebody reads off the assertion, it has some kind of value and meaning in context. New cut is empty. It's a very self-explanatory phrase because it is a new cut. That's what matters about it. Here I can leave it as cup, or I can change it as cup to be filled. I can talk about its role. Okay. Refactoring allows you to get away from some of the overhead, and you want to read this in context. That's the idea, is use role names. Tell me about what's actually going on here. So D, yeah, not so good. The next thing is date. One of the reasons I chose date, there are 3 ways of writing dates that are common on this planet. There's the right way, there's an acceptable way, and there's completely the wrong way. Just to give you a hint about completely the wrong way, that's why we have an Atlantic Ocean. The right way is year, month, day, ISO 8601 ordering, because that lexically orders. My kids think I'm weird to use it on my phone and my laptop, but that's my job. I'm a dad. I'm supposed to be weird as far as they're concerned. So that's the right way. From any geek's point of view, year, month, day is the one true ordering, okay? Now, in public space, I will write things out. I had a really weird experience at the beginning of this week. I had to write a check. It was such a strange experience. Last check written in 2011. But I wrote the check out using day, month, year ordering, because that's conventional in this context. Okay? Now, but then again, there are lots of APIs that expect you to do month, day, year, middle endian. Okay? Now, the problem here is that I've not really told anybody anything useful. The first statement in 111, what is that? That could be anything. I mean, it could be any one of those three orderings. All of them are acceptable. So the idea here is not whether or not that's good data, it's whether or not it's communicating anything. And at this point, it's communicating nothing. The next thing is also, something I see occasionally when people are trying too hard to follow the there must be only one assertion rule. They cram it all in using ands. Okay, so now if it fails, you know that something doesn't work, but you have no idea which one it was that failed. Was it the year, the month, or the day? So even at that level, now that also tells us something else. It turns out that today is not a good day either. I mean, kind of it is. I mean, we're probably using ISO 8601 ordering in this case because people don't write year, day, month. But if you really want to be quite unambiguous about this, choose something that leaves no doubt in anybody's mind. Okay? So what we're talking about here is the selection of data. It's a very subtle thing. Choose data that is not, that communicates. So when people read it, they immediately have the concept in their head. There's no ambiguity. So sometimes I have that when I'm looking at certain things, check-ins or websites. Am I looking at something that's giving me US date ordering, or is it giving me standard European ordering? And I'm looking at it and it's giving me a date, something like 8/6. I have no idea whether 8/6, 2013. I have no idea whether that is the 8th of June or the 6th of August. That's for me to try and figure out, but if you're writing a test case, you have control over this. Make it unambiguous, make it totally clear. If it is supposed to be middle endian, then go ahead and write 6/28. There's no ambiguity there. Okay, so use data that is appropriate. In many cases, we have data that is ambiguous. We use numbers that could mean anything. Try and use numbers that quite obviously represent a certain idea. And names. Don't just test everything against characters from Lord of the Rings, because most of them only have one name. People normally only pick Frodo. They don't pick Frodo Baggins. You need to use first and last name if you're using names and things like that. Communicate a typical scenario. So we've got that. Okay, now, to be fair, so the way people, this kind of works. I'll leave it as it was, because I think I have end unit running here. Oh yes, good idea. Right. So the next thing we do is we go on to the assertions related to failure scenario. So something that people might do is constructor is correct. Well, so people might say date constructor, and then realizing that they've actually mixed their concerns here a little bit. Date constructor exceptions. Now on that, okay, that's a little clearer, sort of, except although it's a valid distinction at one level, the names are still not helping us. Date constructor exceptions, date constructor. Well, surely date constructor's behavior includes its exceptions, so therefore, logically, these names are not really telling us what we wanted to know. The other thing is that what we've got here is these different scenarios. So we've got a throws here. New date 2014 minus 120, so we throw then. New date 2014 1320. New date 2014 3 minus 1. New date 2014 232. Now the problem here is that this, although it kind of looks like somebody said, okay, we're going to sit down, we're going to test the rainy day scenarios. They haven't really done a particularly good job of it in this case. because it's all sort of muddled together, because what we've got here is these are negatives. That's negative month, that's negative date. This one is wrong because it's over the upper bound. This one is wrong because it's over the upper bound, but it looks like we're trying to do a leap year kind of check, but actually we've chosen something, we should have chosen 29 here. So I can see lots of gaps, and we haven't tested for 0 anywhere. 0 is a kind of special value. So I'm kind of sitting there thinking, well, I don't feel very comfortable about this. We haven't really communicated. So let's sort of, let's start by improving this. I'm going to get rid of that because that's really particularly helpful. I'm just going to change that to date, because I haven't got anything more inspirational to provide in that particular context. I will make that less. It's my sister's birthday, which is a good reminder at this point. So that's a little more helpful. Down here, well, we're also getting the sense that I want to probably cover a little bit more of the space up here. So one of the things that I can do is split these out. First thing I'm going to do is rerun this. And do runs. Then we're going to extend the range. And it's going to be a little bit easier if we don't adopt this style. Let us use a test case style, which in this particular case is easily afforded by NUnit. So let's put in 2014, 1320, okay. And in fact, what I'll do is I'll just sneak those in. Oh, love that. Somebody needs to tell Microsoft about, I don't know, threading and cores. I think I've got quite a few spare cores on this machine. And the idea of doing background tasks in the background. Are there any Microsoft representatives here? Any MVPs? You can go and tell them. This is a really cool thing that somebody came up with called threads. It's really great. Okay, so let's go and swipe some of this data. Okay, so we'll go and swipe that. And so what we're going to do is we're going to abstract out the... Oh, I've already got that one. It's not very helpful. Smart. So we'll abstract out the essence of what's going on here. So it leaves us with a very simple assertion model. And then we can extend it. It becomes a lot easier to focus on. Let's check it works before we break it. Okay. So the first thing we can now do is look at our data and realize we're missing the zeros. It's now much more obvious. We can focus on that. So let's throw in some zeros. Okay. Now when we run that, we get some fails. Specifically, the classic case of overlooking edge cases. Okay. Classic case of overlooking edge cases and getting confused by various forms of indexing. There we go. So that works. Right. So the thing here is that when you start factoring these things out, in other words, here we have this, it allows us to see the gaps. I can see more obviously, I can concentrate on the quality of that. I can talk about that without talking about this. There's a zero case there, I can see that. I can see 13, that's good. So that's all the month stuff. Then I've got -1, I've got 0 there. But it turns out I haven't got the 29th of February, which is probably what I really should have been doing. rather than doing 32nd of February, which is independent of leap years. We haven't really done any leap year validation here whatsoever. So let's choose a different month to avoid distracting people. That's the thing. Choice of test date is a very subtle thing. If you're using February and you're doing dates, you're using February because you're going to do something with leap years. Yeah? For anybody that knows about dates, February is weird. Okay? So if February appears, then it's not just arbitrarily chosen. April was arbitrarily chosen because it's currently April. I could have chosen November, and that would have been just as good. But if you're using February, you better be doing something to do with leap years, otherwise you are willfully misleading the reader. They have built up an expectation. Okay, so the point is, let's get away from that. We also happen to know that actually there's a nice little edge case here, that's 31, and that should fail. And does the right thing fail? Yes, indeed, it does. Good. So it does fail, except it doesn't fail the way we wanted it to. It fails when it should be passing. It should be rejected. It turns out we haven't really been very good at testing the edge cases. Notice they were all testing the lower bound. We have an off by 1 error. The internal table indexes from 0, but to be friendly to people, we've chosen to count from 1. So we've actually that's been completely incorrect all this time. And there it is. So therefore, it tells us that what we need to be doing is checking a little more diligently around the end of the month. And then we can get on to February. Okay. Now, if we start looking at this, let's do a leap year thing, which this year is not. Now that's been fixed. Okay. Right. So let's start. There's another thing going on here. There's actually 2 different groupings. One is months out of range, one is days out of range, but they've been mashed together. So now although it's comprehensive, well, fairly comprehensive, I'm going to skip a bit, but although it's fairly comprehensive, we've now got 7 test cases, or seven specific sets of data. Pretty much anything more than about 3 or 4 is going to be hard to read. If we're careful and considered, we will look at them and realise, actually, there's a difference here. Some of them are to do with months, some of them are to do with the day violation. So what we're going to do here is, and I will confess to copying and pasting at this point, and what we're going to do here is, let's see, those are all months, and those are all days, okay. Date constructor exceptions, okay, so clearly here, the date constructor, poor name, date retains given year, month, and day. That's a starting point. Let's see. Months out of range rejected. Let's start with that. Days in month out of range of month rejected. Now, those names are not perfect. However, they are somewhat more specific than they were before. This is how you should think about names. You should think about them as being written in an impermanent form, that they are always your best current guess. And you may come back to them and go, you know what, I've got a much better naming convention for that. Okay? But days out of range of month, okay, well, that's pretty reasonable. It's now much more specific. Date retains given year, month, and day. Yeah, that seems fairly specific. Months out of range rejected, that seems pretty specific. But a common objection to this approach is, if you look, the body is identical. And a lot of people focus on the implementation code. That's not interesting. The meaning is different. In one I am testing months, in the other I am testing days in the month. I can actually split this more in a more fine manner, which I won't do at this point, to really start exploring the question of leap years, which have their own kind of logic, and they're great fun. But I would continue subdividing along this path, being much more and more specific. But the name, it doesn't matter what that line of code does. Actually, it does, because I'm not happy with that. There is one thing I don't like about this. Don't use throws. Use catch. It's one of the other reasons not to use expected exception. If you're using a testing framework that only allows you to check that a method throws an exception, then you have no choice but to use that. So expected exception, as I had with the cup. If you're using a framework that allows you to pinpoint precisely the expression that will throw an exception, then you always use that in preference, because you won't get any false positives, which sometimes, if you've got a bit of code and an exception gets thrown before you were expecting it, the test will still pass, because the exception was thrown, just from the wrong place. You want to make sure that it's that line there that causes the exception. None of the others. Anything before that fails the test. So you want to be very specific. It's this expression here. The other thing is you're not interested in what type is thrown. You're interested in what type can be caught. This currently catches an argument exception. But if I further derive from argument exception to have date argument exception, this will continue to work. And so will all of the catch statements written against it. In other words, this is how exceptions are actually used. They are used by catching. You don't care about the actual type. You don't catch an exception and then do a type check on it. Well, I say that. Let me rephrase that. You shouldn't catch an exception and do a type check on it. I have seen code that does this. This is not a good thing. Okay? So really, if you're using expected exception specifically with respect to NUnit, don't. Be a little more general in this case. Now, final thing here, can compare equal. So as I said, we continue subdividing this. The final thing to look at is dear old can compare equal, and get hash code works. There's a couple of things here. Somebody's clearly tried very hard to avoid calling it date 1, date 2, date 3. That's also not helpful. Date, another date, yet another date. The role played by this that compares equal. Should we come up with another name? Date that compares unequal. Might even be spelled correctly. There we go. Date that compares equal. In other words, tell me why it's there. Okay, that's it. That's what the job the name should be doing. That's always the job a variable should be doing. But in this case, really tell me why I've got 3 date objects sitting there. Also, the subdivision I'm not going to make, because we've got lunch heading towards us. By the way, get hash code, that's actually incorrect, but that's for a later discussion. This equality contract is not properly checked. First of all, you're not checking the expression. Are equal? No. Is true. If you are actually testing the equals method, then you need to have that method exposed for the reader to see. It's not about NUnit or another framework calling it. If you're testing something, then show the reader its invocation. You're not expecting that one equals the other. You're expecting that the result of equals is true. That's different. You're actually testing a different level. Okay? So that's the correct expression for that, and logically also is false for the next one. The other thing is that if you separate this out, it looks like we've compared equality. We've compared a thing against something that was constructed the same way. We've compared a thing against something that was constructed differently, and they should be different values. The problem is we haven't really tested all of the equality contract. And it's not obvious, because we haven't got a name that tells us. So I'll kind of close by considering the names of the things that you want, and in this case, this particular code will fail. What you want to do is that, let's talk about the contract for equals. In this particular case, identically constructed dates are equal. That's the name of a test. Dates constructed with different values are unequal. Dates never compare equal against null. The null hasn't been discussed. We also haven't checked against other kinds of object. Dates do not compare equal against non-date objects. That gives you 4 test cases. Now, you can't see the contract specified here because somebody's called it can compare equal. They try to roll all 4 cases into one and forgotten 2 of them. But it looks plausible because they kind of focus on the main things. What we're talking about here is that is a very common smell. They roll things together because they're afraid of the number of methods they'll have to write. You are not taxed on a method basis. Writing a new method is like writing a new line, actually. That's all there is. Now, occasionally, there's one final smell I want to close with in this particular context. Occasionally get asked about what about using the extra string messages? You can attach a message to in many assertion frameworks. There's an extra overload that allows you to communicate a message in the assertion. My suggestion is not to use it. My suggestion is if you ever find the need to use it, what that probably means is you need to actually partition your test cases into smaller test cases. So, for example, if I found myself tempted to add an extra message here saying identically constructed objects compare equal, then that should be the name of the test case. If I add in an extra case just to check for null now that I've observed it, I don't want to say it should not compare equal to null. I want a different test case for that. The name of the test case is a comment, but actually it's a comment that will be picked up by the test runner and therefore made visible at the top level. When you fold everything away in the editor, what you're left with is a specification of the behavior. So the full contract for equals for an immutable object is identically constructed objects compare equal, differently constructed objects compare unequal, the objects never compare equal against null, and they never compare equal against something that is not of the same type. Those are the 4 things. You should always see those there, and there should be 4 different test cases for them, unless you wrap it up in some convenient helper. Okay? But that helper should then be as equally as explicit. You should check these thoroughly. So the idea there is this subdivision, much more fine-grained, Really use those names. And that point about the names is one of the most important things. Sometimes people think, oh, naming is just naming. Remember what your tools are. When you are writing code, you have naming, spacing, and punctuation. That's it. So if you say, oh, it's just naming, you've just thrown out one of the 3 main tools. It turns out to be quite a big one, this one. It's the way you communicate, and that really is the key idea. Most of the smells, there are structural organizational smells with tests, which are kind of like for part 2 of this talk, which I may do next year. There are structurally related smells, but in most cases what we're talking about is smells that are related to how we think about the communication, where we just think of it as just like, I'm just writing a piece of code that's throwaway. I'm just testing this to see that it works. And it's actually using the naming to drive the subdivision. So the thought to leave you with, given that naming is one of the most important points here, because it's actually driven the structure, a good name is not merely a good label. A good name should change the way the reader thinks about the code. It will actually change the way that they approach it and what they're prepared to expect, and also how you will then subsequently subdivide things. I'm around not around immediately in the afternoon, but I'll be around later, and I'm around tomorrow morning. So if you've got any questions, please catch up with me, otherwise tweet at me. Thank you very much for your time.